5.2, number 114. We have the function f of x equals sine x, and we're on the interval a equals 0 to b equals 2 pi. So there's our 0 to 2 pi interval that it must be talking about. We're supposed to find the average value of the function. Find f average. So f average is the right-hand side of the mean value theorem for integrals. So we said mean value theorem for integrals was that there exists a value c for continuous functions where the function will be equal to its own average value, is the idea. Okay. So this calculation here is what the book calls f average, the average value of f. Okay. And for a continuous function, there will also be a special value c, at least one, it could be more than one, but there'll at least be one, that causes the function itself, right, to be the same somewhere as its own average value. Right? So there's two things going on here. There's the average value of the function, and then in special case for a continuous function, there'll be a number that causes the function to evaluate to its own average value. So when it says find f average, it means compute this integral. Okay? So for us, that would be f average 1 over, in this case we're going from 0 to 2 pi, so 2 pi minus 0, integral 0 to 2 pi of the function sine x. Now, there's two ways to look at this problem. One is, even though this is happening in section 5.2, and we don't have a lot of rules in 5.2 yet, nevertheless, we have gone through other sections, so therefore we could calculate this directly, and that's what I'm going to do right now. And then I'll show another idea about how to go about it, even if we didn't know how to do this directly. Okay, so this should be the same as 1 on 2 pi. The integral of sine x, its antiderivative is negative cos. Negative cos x 0 to pi. Okay, so let's see what we get. We'll get 1 on 2 pi, and I'll just take the negative out here. And now I'll evaluate cos of 2 pi minus cos of 0. But cos is a 2 pi periodic function. So therefore, even if I didn't know what cos of 0 was and cos of 2 pi was, I would know that this difference would have to be 0. Right? Wherever you start, if you're 2 pi later, cos is going to be the same value for each of these. It's true, it's 1. I know it's 1 minus 1, but I'm saying if you didn't know the exact value of each of these separately, you would know their difference was nothing. So we get negative 1 on 2 pi times 0. 1 2 pi times 0 equals 0. So the average value of this function over the 2 pi interval from 0 to 2 pi is nothing. Okay? Now, we're also supposed to find a c value. Okay? Find c such that f of c equals f average. Okay, that's what this is saying here. Find the value c, right? There is a value c. Now the book's telling us to find it. There is a value c such that f of c is its own average value. So here we would take sine of c equals f average, but f average was 0. So sine of c equals 0. But c has to live in the 0 to 2 pi interval. C has to be in the original interval. There's actually 3 places where that would happen, right? On this interval, we know that c could be 0, pi, or 2 pi. Now, if we just take the inner part of the interval, right, excluding the endpoints, we would certainly pick c equal to pi. That would be our location we would want to deal with. So I'll just pick that one, okay, although the other two are legitimate because this is a closed interval. But let's just pick this one. Okay, so we found a value, right? F of pi equals f average, because we know the sine function, and this value was 0. Great. Okay, so we solved the problem, but I just want to demonstrate another way to go about it if we didn't have the skills to evaluate this integral directly. Sometimes there's other ways. So let's look at a picture of this sine function. And we'll see why its average value is 0 here in a moment. But the interval is 0 to 2 pi. So here's pi on 2, pi, 3 pi on 2, 2 pi, and here's -1 and 1 perhaps. So from 0 to 2 pi, we should get something like a peak here, a trough here, a peak here, and I'm sorry, that's not true at all. A peak here, a 0 here, what I meant to say, a trough here, and back to a 0 here. All right, so let's draw that. Okay, so there's from 0 to 2 pi. If we now shade in the area that we were talking about, so what is the red? The red is the integral of sine x from 0 to 2 pi dx. That is the red in the picture. That's the area there. Okay. Now, the whole interval, right, here is 2 pi minus 0 long is 2 pi. But we can see from this interval, right, over which sine is defined, that the area here is positive, area here is negative, and they are exactly the same in magnitude. So therefore, even if we didn't know what this value was and this value was, again, you can see from the picture, which is what I think the book is hinting at, that they are exactly the same magnitude but different sign, because one's above the x-axis, one's below the x-axis. So therefore, there are some, right, when you add up all the area together for this integral, it's going to be 0, which is what we got a moment ago using the direct method of antiderivatives. So now all we're claiming is there should be some place in here where the function takes on the same value of 0, right? Because the division by 2 pi here did nothing to alter the value of this area being 0. Right? So what is that location? Our claim was that c was pi itself. Right? So right here, right, this is pi comma 0. So we see here that the function value, right, this is f of c, and the pi value is the c value itself. Right? So there's our location, c equals pi, where the function takes on the same value of 0 as did the average value of the function over this interval. That is the area divided by the interval size.